question number 12. So what happens here is they say, as you know, when the course ends, students start to forget the material they've learned. Okay, and we have an Ebbinghaus model, which tells you that the rate at which student forgets the material. Okay, so I'm going to tell you this: the rate at which student forgets is keyword proportional. Okay, that's a keyword to the difference between the material correctly remembered at the point and some positive constant a. Okay, I'm going to put that down here too. To the difference, another keyword. Okay, it's proportional to the difference of what? Material currently remembered and some constant a. Okay, this is how we have this idea here. Okay, and they want you to make sure that you're able to formulate an equation that tells you the derivative of this thing. Okay, so we have to make sure we understand this little literature they've given us. Okay, so the rate at which the student forgets is this. Okay, and in part A, they've told you that let y be the fraction of the original material. Okay, that is remembered after t weeks. Okay, and that's very important. So they've told you it's a fraction, but as a person forgets, right? As a person forgets something about it, of a course, this fraction will go down. This will go down as you kind of experience this thing. So this fraction will go down in this sense. So we're not quantifying any how do you quantify how much you learn, in percentage, right? So we can do it in a percentage or in fractions. They want to choose fractions, so it's their choice. We're given that y is the fraction. Okay, so we know the material currently remembered is going to be denoted by the variable y. Okay, they've given us it's going to be a difference with some constant a, so cool. And we need to figure out a differential equation this. So we know from the given statement is that the rate of change of how much you forget is dy by dt. Okay, because rate at which students forget is going to be dy by dt, which is the change of the fraction that you remember, right? That dy by dt is proportional, so the proportional will have this red proportionality there, to the difference between the material remembered and some constant a. So I can be like, this is y minus a. Cool. Right? This is what it is. But this model is not just perfect, We have to make sure we have a differential equation, not a differential proportionality, okay? So we have to do this. So this is dy by dt as a k, y minus a, where k is a constant of proportionality. Okay? How do you feel about what I've discussed at this point? Does everybody see how we constructed our differential equation? Right? There is some extra information given to us, which we're going to add into this element. And before, I need to make sure everybody understands what's happening, right? Okay, good. Now, the key question. Is y decreasing or increasing with time? Tell me. Should it be decreasing, increasing? I have 1 decreasing. Does everybody else agree with that decreasing? Okay. Yes, which is good. The reason why it's decreasing because y is a fraction of the original material. And then as time progresses, you're going to forget, So the fraction is going to go smaller and smaller and eventually, go to some value. So that's what's going to happen, which is good. Now, what we have to do, though, is to look at part A and look at their constraints that they've given us, okay? They've told you that k needs to be bigger than 0. So they've told you that. Okay, so this part of the equation is positive. Okay? So that's fixed. Cool. With the concept that you just told me that the dy dt is going to be decreasing, what do you think should be the sign of this whole thing? Should it be negative, positive? The whole thing. Remember, it's decreasing. Should be negative, right? So if you want to have a dy by dt of some quantity that's decreasing, that dy by dt should be negative, right? Because in order to do that. So we know out of this 2 possibility, k is always positive, so that's eliminated, right? It's just out of this world. So we cannot rely on k helping us to get that negative sign. So let's see what other information we're given. They've also told you in the question that the constant a is also positive, and it's always less than y. So if you have a being always positive and being less than y, what do you think y minus a will be? Positive or negative? Positive, right? So that's going to ruin us. We don't need that. We want that thing to be intentionally negative because we want to make this differential equation work, right? So the ambiguity lies here. They've told you the difference between the material remembered and some constant a. Now, because of the constraints given to us, the correct differential equation will be this. That way everybody's happy, That way dy by dt will be a negative number, right? Does everybody agree why this will be the better interpretation of a difference? Because we want to take the difference, cool, but we also want to take the difference keeping in mind these constraints and also keeping in mind that we want to have this dy dt negative. So this differential equation will always be negative for all values of y because a is always going to be smaller than y, hence a minus y will always be negative. Everybody Gucci? So what if we just put a negative behind k? That's also possible. So if you put a negative behind k, it will just eventually, simplify this as y minus a to a minus y. So that's also valid too, But saying that negative k would be, just a different way of interpreting the same thing. Algebraically, they're equivalent. Right? Good. So negative k, perfect choice as well. But you want to have a minus y there too, just chill, right? So we got everybody on the same page, which is good. So now we have our differential equation. That's the answer to part A. Okay? This is the answer to part A. Part B is asking you what is going to be y of 0. So we have to interpret, what do you mean by y of 0? Given that y is the fraction of the original material remembered after t weeks, y of 0 is going to mark how much do you remember at 0 weeks, which means right after you learned it. So what should be theoretically that value in percentage? How much you remember just after it's been taught, 100%, right? So in terms of fraction, that would be 1. Everybody agrees with me on that, right? So that is the answer to part B. So now we have a differential equation, and we also have an initial value, right? And now our job is to be able to solve this differential equation and get to a result, right? So we'll do that in just a second. But you have to remember there are 2 unknowns in the differential equation. We don't know what the value of k is, and we don't know what the value of a is, right? So we're gonna run into some trouble. We're gonna need some extra information. Right now, for now, we can just try to solve this equation in terms of a and k, and we'll figure out the value of a and k after that. Okay? So let's do that. Our differential equation right now, in a part C, would be dy by dt equals to k a minus y. Now you all should agree with me that the only way to separate this is to have a minus y down here and k with a dt. Of course, if you want to be fancy, you can bring the k too, but why? You know, if it's easy to keep it on the right side, we'll keep it there, right? Everybody agree that's how we do that, so we can take the integral of both the sides. This way I will have ln of absolute value of a minus y big equals to kt plus the integration constant c. So now we have a third unknown. Wow, this thing is fun. Of course, ln of a minus y will have a division by -1 because of chain rule of integration, right? I almost missed that, so we're going to make sure I take this negative and put it over there. So we have ln of a minus y negative kt plus c. Any questions about the integral? Nope, that's good. We can move on. After that, we can just take the exponentials on both sides. We have a minus y being equals to e to the power negative kt, of course with the c in the front. So that could be done. And then our equation is going to be y equals to a minus c e to the power of negative kt. Okay, so my solution is nice. It looks okay. Any questions about the method? Nope, right? That should be good. So now we have a, c, and k, which we don't know. So how do we figure out a, c, and k? By the given information. So we know we can easily figure out the value of c. Let's see what we can get. We know that y of 0 is 1. So let's try to plug it in and see what we get. Okay. So y of 0 being equals to 1. That means 1 must be equals to a minus c e to the power of 0, which implies that 1 equals to a minus c, which implies c equals to a minus 1. Okay. Yeah, you can have a negative c, but that's a constant, so we don't really care. Even if you multiply a negative c with a negative number, you know, like have it multiply c with a -1, it will still be a constant, so we're just gonna still call it plus c. You know, it doesn't really change. So that's how we should have it as that. So this is my equation now. So far, my equation looks like this. Y equals to a minus a minus 1 e to the power of minus kt, or in a simple algebraic way I can be like y equals to a plus 1 minus a e to the power negative kt. Okay. So now my equation looks a little bit better because I have only two unknowns to worry about. Okay. So now how do we go about and solve this thing? We have to look at the information they've given to us in part C. Okay. So if there's any questions about this, please let me know right now, or else we can move on to actually finding the value of a, k, and then eventually finding out how much do you remember after the summer vacation. So no questions about this? Good. We can move on to this. In the part C, they've told you that the differential equation and is going to be that after 1 week, a student remembers 90%. So we know that y of 1 is going to be 0.9. Remember, we deal with fractions, so you have to be very careful. And they've also told us that after 2 weeks, they only remember the 85%. So yeah, the first week they lose 10% of the information, and the second week they lose the extra 5. So we know y of 2 is 0.85. So now that we have these two values, we can put them in the equation and try to solve for the unknowns, right? So now we know our equation is going to be y equals to a plus 1 minus a e to the power negative kt. That's the equation. So if you plug in the first problem, so you would have this equation which says 0.9 must be equals to a plus 1 minus a e to the power of negative k times 1. And the other equation is going to be 0.85 a plus 1 minus a e to the power of negative k times 2. Right? These are the two equations that we're working with. I'm going to call this equation 1. I'm going to call this equation 2. So now our job is to be able to solve for e to the power of basically want to find a and k. Right? So how do we do that? This is where it becomes interesting. Because this problem is not just simple algebra. It will require a little bit of extra stuff. So if you did not pay attention, or like for some reason we're not perfectly explaining how to solve exponential equations, it will be a little bit tricky. So I'm going to do this way. I'm going to go here. And from 1, I'm going to isolate the value of e to the power negative k. It will be 0.9 minus a 1 minus a. Does everybody agree that from equation 1, e to the power negative k is going to be that? Okay, perfect. Now I'm going to try to show you that this term is nothing but e to the power negative k squared. Right? So now because that is e to the power negative k squared, I can just literally plug in the e to the power negative k value and try to go there from that point onwards, right? So if you plug it in here, your equation 2 becomes (0.85) equals to a 1 minus a Everybody's okay with me up to this point? Everything's cool? Awesome. Now it's job to solve for a. So we can do that very easy. We can be like, this is algebra, so there's no exponentials here. Let's worry about the value of a. Minus a must be equals to. So one of this thing will be cancelled out. 1 minus a. 0.9 minus a divided by 4 squared with 1 minus a whole squared. So this cancels with that. So then I would have this expression will have 0.85 minus a times 1 minus a equals to whole square. Right? So we have a quadratic, which is inevitable. So we have to solve for that in a sense. Let's try to see what we get. So I'm going to take this expression, copy paste it. So when you expand it, you get 0.85 minus 0.85a minus a plus a squared. And on that side you will have 0.9 squared plus a squared minus 1.8a. Okay, so I can see these a squares will cancel each other out because they're equal on both sides. Of course you can do the algebra and they'll still work out the same way. And I'm going to combine all the a terms on one side and the constants on the other. Okay, so we'll have 0.85 minus 0.9 squared is going to be 0.81. And on the other side you have negative 1.8a with a plus 0.85a and then a plus a. Okay, this difference is going to be 0.4. And that's going to be 1.8 minus from this, so it will be 0.05. There could be a possibility of error. If you see any of this thing, please let me know, because my tiny brain probably can't do basic math. So from that being said, you can easily see that the a value is 4/5. Right? Does everybody see how this algebra works out? Good. We see that A is going to be 4 over 5. Cool. Now I'm going to give you a tricky way. Okay? A tricky way of trying to trick web work in just a sense. But for now, the regular procedure would have been find K, because now you have A, so you can find the value of K by plugging into this expression, right? So we'll do that. We'll find K. That's the first step. Second step, you'll have an equation. So write the equation with the value of A and K. And then third thing is plug T equals to 14 to find the value of Y, because they want you to find how much do you remember after simplification. See, I dropped my pencil. So they want you to figure out how much you remember after 14 days, which is 14 weeks. So you have to plug in T equals to 14 and solve it. But there's one clever way to try before you do that. Okay, so try this. Okay, and I'm going to explain you what's happening. When you're given a dy by dt as K equals to A minus Y, can you tell me what happens eventually? Eventually means after a long, long time. Would you still be forgetting something? Or, you're done forgetting everything and just now saturated to some point? Like if I ask you at this point, what did you learn in grade 11 chemistry? You probably know something about it, not everything. So you can say now it has been eventually enough time for you to do the forgetting part of it, and now you just have a saturated information in your brain, right? Isn't it? So eventually what happens is the forgetting will stop. And when forgetting stops, the dy by dt will go to 0. Okay? Eventually, as t passes, dy by dt will be 0. Does everybody agree with me on that? You see the ideology behind it? Because it's a physical process, right? And our brains have some memory. So we will not probably remember everything, but we'll remember something, and forgetting will stop. Right? So given that it stops, where do you think it will stop? Where do you think dy by dt will go to 0? You can easily plug it in and be like this. So K, A minus Y must be equals to 0. The only way that's possible is if Y equals to A. Right? That's the only way, because K is not 0, and so is not A. So, Y has to be equals to A. That's how much eventually you'll remember, right? So the forgetting will stop when you hit the value Y equals to A, which means that A, the positive constant, they have to start in the beginning. Yeah, so A is always being less than Y, but that is what I want to be very sneaky with. So web work will probably let you do this for some of the values, right? And I want to give you the whole picture too. It will take some explanation. I'll tell you why. So A is less than Y, but can A and Y be very close to each other so that web work will be okay, right? That kind of works out. So theoretically speaking, that the forgetting doesn't stop, because of A being less than Y, this term will always be negative. It will never be equal to 0, and it will never stop forgetting. But in real life, it does happen, right? And why do we feel that happens? Is because the next week after eventual time has been passed, you will not forget much. So as t goes to infinity, or t passes, your value of Y is going to try to approach A, but is always going to be in the sense that A is going to be slightly less than Y. So with that being said, do you think t equals to 14 is a long enough time to, be done with forgetting? Might be, right? Might be that after 14 weeks, you're done forgetting what you want to forget and be like, yeah, I'm just going to remember whatever the A is. Because that's the spot where the forgetting has stopped, right? Or you can still be forgetting. So I'll show you both the versions, okay? I will show you both the versions. I'll tell you how different they are, in the relevance. But the idea is I want to impose is that this is eventually going to reach that value A, and that A is the quantification of how much you can remember after infinite time has passed. Okay? That's what the significance of A is. In the question, they just call it a positive constant, but in the Ebbinghaus model, that is like the ability of brain to retain after infinite time has passed, or like theoretically forever. So that's what this is. So we're gonna see. This is how you want to try it first. Try to plug in the A value you found out and see if Weber lets you, live a peaceful life. But if not, remember, you have to submit the answer in percentage. So don't forget that. Part C has to answer in percentage. So this will be 4 over 5 is like roughly 80%, right? Which is very good for a person to retain. But hopefully we'll see. So we'll see. We'll check the regular solution. So that was like a trick you can do beforehand. But then we can move on to actually solve this whole question and see. So we were given the final value of A is 4 over 5. We knew e to the power negative k is 0.9 minus A divided by 1 minus A, right? Just double checking, yes. 1 minus A. So that should be implying that e to the power negative k is 9 over 10 minus 4 over 5. Just doing that for my simplicity. 1 minus 4 over 5, right? Which resolves e to the power negative k being equals to 1 over 10 divided by 1 minus this will be 1 over 5, right? Which is just going to be e to the power negative k being equals to 1/2. Right? So that's what we have as e to the power negative k. Hence, your k value, or negative k, will be ln of 1/2. In particular, in my case, not in everybody's case, okay? In just my case, that's what it is. And then, which will be written as k is equals to negative ln 1/2. And this is an overkill. After this step, we already found out k, but I'm going to do a little bit extra to kind of show you. You have k being equals to negative ln of 2 to the power minus 1. And because of property of ln, you can bring the negative 1 in the front. So k, this exponent will drop down, will be equals to ln of 2. So that's the value of k. Okay, so we've done the first step here to find the k value. That's done. So now we got to write the equation after the known value of a and k. And now this question is looking like it's horribly long, but it's very important for me to tell you the concept of differential equation in this question, because this is the best example of a thing that can probably be asked on the exam. Okay, so here my solution will be y equals to, now the value of a is 4 over 5, 4 over 5, plus 1 minus 4 over 5, e to the power of ln 2 t. Right? So k is that. Remember, we have a model with a negative value of k. So we have a negative k, so we're going to make sure we don't forget that. Negative this. Which, in simple words, will be 4 over 5 plus 1 over 5 e to the power of. This could be simplified a little bit more. Okay, I can do it like this. Because of the exponent rules, I'm going to show that here. You can write this as times ln of 2, right? And because you can bring down or take it above, you can take this exponent and raise it to the power of 2 to be written as ln of 2 to the power of negative t. So when we have done that, we can be like, okay, this is cool. So now, e to the power of ln of something is just going to be 2 to the negative t. Right? So that's very important. So this further simplifications into the final step. Final step is this is the solution to our equation in its all glory and simplification as we can get. Okay? How do you feel about this page? I know this was a little bit of extra algebra. That's why I wanted to try, see if your Weber accepts the a value to be the correct tolerance. If not, then you have to go through this whole pain of doing the algebra. But does this make sense? The work makes sense, right? Any questions about any part of the calculations that I did? Yeah. This is like you're visiting all this pre-calculus stuff after a long time. So this might look a little bit, worrying in the sense that you don't remember it on top of your head, but trust me, it'll be fine. As long as the work makes sense, the practice can, deal with that. Yes, for sure. Ask a question, please. Yeah. Oh, that's because of this rule. So watch this corner here. When you have e to the power x plus c, right? The rule of exponent is to be able to break this down into e to the power x times e to the power c. Okay. Now, because c is a constant, so is e to the power c, right? So I'm going to call this some constant capital C. So that eventually resolves to be e to the power x times some capital C, or in other words, c e to the power x. Right? Yeah, because c is a constant, so is e to the power c. So I'm just going to, get rid of the whole context and combine them into one single number. Right? It's not the same, yes. And we don't really care. All we want is to have a constant, associating with this ambiguity of finding a general solution. That could be the c that's in the power of e, or it could be the c that's just multiplied to the e to the x, right? So both the way, it's fine. Awesome. Right, let's go. So the final equation here, I'm going to get rid of this so that we have our final equation, y of t being equals to 4 over 5 plus 1/2. No, 1 over 5. 2 to the power negative t. And the answer they're looking for is the value after 14 weeks, so y of 14. To the power negative 14. Does everybody agree this term is going to be very tiny? Because 2 to the power of negative 14 will be a gigantic number in the denominator. Right? So that way it works out. So now we're going to check how small that is, right? So let's do that here. So we're going to go here and like the calculator. So I'm going to plug in the function here. F of x being equals to 4 over 5 plus 1 over 5 e to the power of, no, not e to the power, 2 to the power of minus x, right? And we are only looking for these values for bigger values of x than, x bigger than 0. Because x is literally depending time here. So we're going to do that here. If I just want to see the version that's going to be taking all the values of x bigger than that, I'm just going to do this. So you see this curve looks like this. This guy is very smart. Whoever is being modeled in this Ebbinghaus example, he's very smart because amount of fraction that he remembers after a long time is pretty high, right? Because the fraction needs to stay below 1. So he's like almost remembering 80%, or whatever the person is remembering about 80% of the information, right? So that's how it looks like. I want to figure out how much does it remember after 14, so I'm going to say my naive guess was it's going to be just 4 over 5, which is 0.8, right? That's the naive guess, or 80% of the fraction. Let's see how much exactly it is, right? So if I do f of 14, that's 0.800001200 blah blah, right? So the whole intention of trying to plug in a before you go through all the algebra to get the value is to be blessed by the web work that it accepts 0.8 as an approximate answer for the actual answer. Do you guys see why I wanted you to save you from the algebra, right? Because they are effectively very close. And we just need as close as the web work would take, to kind of get through the problem. Given that you know the method, right? So 0.8, try it out. If it works, cool. If it doesn't, then you might have to make sure that you solve all the work and then get to a number, which is going to be like this, right? So does this make sense? Why and how we're going to do this whole problem, right? This is probably going to be the longest problem. People will have trouble with it too. And that's why I wanted to discuss in detail so you guys are able to, understand every bit and piece and, kind of like relearn the question when people ask questions in the group chat, right?